In previous video, we have established what kind of quantity sound intensity is. Let's now look at how it is measured. The sound intensity can be calculated as the product of the instantaneous pressure and instantaneous particle velocity. The sound pressure in a given point in space can be measured directly by using a measurement microphone. However, particle velocity cannot be measured directly, but can be calculated from the gradient of sound pressure, which in case of sound intensity is approximated by a difference in sound pressure between a pair of microphones. This way, the sound intensity is fully determined from the sound pressures measured at each of the microphones. The sound intensity is therefore measured by a pair of microphones, typically denoted microphone A and B, which are held at a constant distance by a spacer, and together they form a sound intensity probe. The microphones for the probe always come in pairs, as they are selected to have a minimal phase mismatch. The order of the microphone matters. From the formula for the sound intensity, we can see that if we exchange pressure A and B, for example by turning the probe for 180 degrees, the sign of the sound intensity changes. In other words, the sound intensity coming from the direction B to A will have negative sign, and the one from the direction A to B will have a positive sign. This means we can tell the direction of the sound energy flow only by observing the sign of intensity. The gradient approximation only works accurately enough in a certain frequency range, which depends on the spacing between microphones. So we use spacers of various lengths to cover different parts of frequency spectrum.